with my talk of tomorrow. It seems to me that, of course, energy is considered to be a fundamental problem. And there are two elements into this. First of all, the rapid population increase. When I was born, I'm not that young, but not that old either, I suppose. Okay, so when I was born, the number of people on Earth were 3.7 times less than that today. So over these famous years from my birth to today, your population got multiplied by a factor of 3.7. And the energy, that's your question here, is the energy question, primary energy of the planet demands to mankind. It went up by a factor of 11.7. So today we are producing per unit of time more than 10 times the energy which was available when I was born. Now obviously it is quite clear that the new generation of people which are born today, and let me remind you that today every second there are 2 new people born in addition to the ones which are there over the planet, with 2 persons per second, and whatever number it comes every year, then a billion every 10 years, it is quite clear that in those circumstances, the energy is available, and the resource available can no longer be an extrapolation of what I have been doing myself. You cannot take another factor 10 or 11 or multiplication for the young people, in addition to the factor 10 we already had in order to live the way we lived, in one way or the other. So something has to be changed. We passed a limit, and things have to be different. And of course, energy is the key to the question. If you think that from the moment of the beginning of this industrial revolution in the last 250 years, 1 million tons of CO2 have been emitted in the atmosphere, and it is rising very fast, very quickly, and the resources are what they are. Our planet is the only thing we have, and therefore we have to have a much more serious concern about the situation and concern about the future than it was when I was born. When I was born, I think it's much easier, because we were free running, we were going ahead, free, without any conditions, without any limitation, without any questions. But now we can no longer do that. Now we have to change our things. We have to change our things very dramatically. And we have to be honest in doing that. We are particularly capable of making that, giving a chance to everyone. And as you remember, there are many people in this world. There are people which are rich and wealthy, but many, many more people which are poor and needy. And we have to take into account also that aspect together with the others. And certainly energy is a key. Health is a problem, of course. Energy is also one of these problems which we have to answer to. So the question is wide open, and the answers are many. In my opinion is that there is a big disagreement today between the growing demand on the fact that energy, the cheapest energy is the best energy, and on the other hand, fossils and so forth and so on. On the other hand, we have the fact that we cannot continue to live in these conditions because we reach our limit. So, I mean, it's everybody's problem to solve it, because if we don't solve the problem of energy, we will not solve any other problem. Anyway, I hope I answer your question in a certain sense, if that's what you said you want to hear.
Thank you. That was a summary of your lecture tomorrow, right? Thank you. Further questions? Thank you. Go for it.
Thank you. My name is Herman. I'm a PhD student at the Center for Quantum Technologies. I'm from Finland. What I often struggle with is that my friends ask me about what my research is about, and quantum physics is maybe not the easiest thing to explain always. Now, I presume that you as Nobel laureates have extensive experience in explaining science to the layman, to the public, and I would like to ask, well, all of you, but maybe Dr. Rubia, since you're a physicist as well, on some advice on how to do science communication, how to explain science to the layman.
How do you explain particle physics for your wife?
Well, it would seem to me that it would seem
She
to me
must
that
be a
in fact
particle physicist, so he doesn't need to explain it.
we are facing, in order to proceed, well, first of all, let me say, many of the subjects, for instance, astronomy, astroparticle physics, the beginning of the time, the Big Bang, and everything else, for a very long period of time, has been a philosophical statement, an issue which was based on the assumptions of belief, of opinion, of religion, and so forth and so on, which have really mostly dominated the way in which we were conceiving the universe, especially the beginning of the universe, which is of course the key of everything. Even the fact the universe has a beginning was for many years considered to be a surprise. Even Einstein had some kind of real problems in asking himself whether there was a beginning of time. Now we know it is so, but now the situation is, over the last 15 or 20 years, we have changed the situation from a philosophical argument to what I would call an aspect of natural philosophy. Now the situation is based on proper, good experiments. For the last 15 years, or 20 years or so, the happenings of the universe in the early days are no longer a question of belief, but based on very fundamental, very precise experimental measurements. And a very large number of measurements have become, and today to talk about the Big Bang is like to talk about any experiment. It's not a different experiment. It's something you can also do with the same spirit, with the same, and let nature decide in your place. And what is unbelievably a result of this is that the number of surprises coming out is absolutely enormous. For instance, we have the dark matter story, dark material story. 95% of what is constituting the universe is unknown to us. Now, this, for a young person like you, should be a tremendous challenge to get going and figuring out better than what we do today, what's the answer to the question is. And so there are many other issues which are coming out every moment from this kind of situation, which in my view are a tremendous opportunity for the people to study and to understand and to develop in a most efficient way. Second thing, for instance, we think that when the universe expands from there being a little thing at the beginning to what it is today, it's blowing up. Any object, natural object, it blows up. The bigger it becomes, the more it slows down. So the universe at the beginning is moving fast, and then after a while, you would expect it, that it will slow down because it has to fight against the gravitational force, which is stopping the object from moving. That's not true. What we know now, experimentally, and this is another important Nobel Prize which has come in the last few years, that indeed we have an acceleration of the development process, that the universe with time does not slow down, but speeds up. So it gets faster and faster the further we go. Those are things which are, of course, give you the real proof that the science now is a real subject which is based on not on preconceived ideas, but based on experimental results. And as usual, nature is always the winner, and we have to be very modest. We have to be very, very concerned of the fact that we have to accept, instead of nature, before what the nature said. Socrates was reasoning, thinking in a different way. Now we need somebody which is, and this is the great strength which comes from physics and from other fields today. Now the other important question is, there are no things which are not relevant. The curiosity is the main mechanism which has brought the men out to onto the moon. This is not wisdom, is not authority, is curiosity. Many of the phenomena which we see today, which seem to be completely useless, tomorrow will have a tremendous and fundamental application in science. For instance, synchrotron light sources, for instance, are using relativity. I mean, how can anybody think that relativity can be used to run an experiment in the detector which is producing synchrotron light, and so forth and so on, for many different fields. So the fact is that the prime interest of science has to be the one of listening to nature modestly, carefully, with a great deal of respect that what's going to happen will be probably different than what he ever thought.
Good. Listen to nature, that's good. More questions? Here we go. Everyone is standing there. Good. Go for it.
Right. Is this working?
Yeah.
So my question goes to John, I guess.
Yeah.
Or
He's ready. He's
right.
ready.
Some of you, anyways. So when it comes to the science of medicine and chemistry, I guess it merges a lot with physics. Because you are down to the
We have very
particle
young
physics
students at
and
NTU.
quantum chemistry and so forth. Do you see
Yeah.
in a future that the
No,
subject
the
will
baby
be
is
maybe
gone.
merging? And is there any, I mean, in the fundamental research today, is there any difference in how you see your research compared to what
called NTU
physicists
also.
are seeing their
National
research?
Talent.
You were saying a long time ago science was science and then it split into
Actually, I
disciplines, but
was
you're saying it's
invited
going back.
to
Maybe,
summer
I don't know.
camp.
So what are you saying?
But
Is
the stage of
chemistry,
the
medicine and
camp, so I
physics
didn't
going to
come
work
back.
in some
But
sort
I
of
went to
interdisciplinary soup?
Academia Cinema.
Taiwan science camp up in the
Yes,
mountains.
essentially the answer
So
to the
basically
previous
through the
question
airport
is
and
that
went to the mountain and back. And I
already
kept on talking
in
about
elementary
NTU, they
school
were
you
getting
have
very
to
confused
train
because
people with
it's
some
this
scientific
university.
Yeah,
concept,
I know.
especially politicians who
This one is
make
famous.
decision.
NTU is
Then
very
we
famous.
have a common
Yeah.
language. Now, there is no doubt that a lot of medicine, or at least biochemistry, will be simulated by chemists or physicists, and there will be more and more computer-based description of biochemistry and biology. It will just happen. One day you will even have a computer program where you type the name of the protein and you see what it does. Still a long time. So the answer is that there is already a lot of emergence of these different fields because they are basically one thing, what molecules are doing. And I mean, you could do it without knowing about the quarks, but the forces within large molecules could be learned and would be a common thing to study.
Oh, you want to add to that discussion? Yeah.
Well, I can agree with that, really. I mean, it's not an area I've been involved with, but certainly biochemistry and similar things are becoming more and more involved in general medicine.
Yeah. Of course. And it's interesting, you know, when we decide upon the Nobel Prizes in Stockholm, in the previous day, you only have to go 20, 25 years back in time. There was one distinct committee for physics, one distinct committee for chemistry, and one distinct committee for medicine. Still is. But once a year they have common meetings. So they would not get to the embarrassing situation that we would give this same person both the physics and chemistry prize. And of course that proves a little bit your point that things are becoming more and more, because there are several scientists, I cannot say who get nominations both for the physics and chemistry prize or the chemistry and medicine prize, by the way. And I have been involved in announcing the prize to a person that who had won the chemistry prize. It was for sodium potassium pumps. And he was so convinced that he had received the Nobel Prize in medicine. I really had to say, no, it's not the medicine prize you received the chemistry prize. So that is a little bit like that. Okay, more prizes. No prizes, no more questions, I mean. Good, go for it, don't be shy.
Hello. So this is Ezekiel from Argentina. I'm a PhD student in civil and environmental engineering. So a question for Professor Warren specifically. Can you describe the aha moment that led you to the discovery for which you got the prize? If there was an aha moment, no, like the Eureka one. And then the role of your teammate and possibly your mentor in that, if they could be included.
Good. When was the decisive moment? Yeah.
when I first saw the bacteria,
When did you really came to the decisive moment and you would say, it must be bacteria and not hydrochloric acid?
I'd been working with the bacteria for a couple of years, and I met Barry Marshall, and we worked on them together. And a year later, we did a study of. So I was just a pathologist, and I was just doing the pathology. Didn't involve the clinical work, including ulcers at all. But with Barry Marshall doing the clinical work, we could combine clinical and pathology. And I could see what was happening in the pathology, and he could see what was happening clinically, and we could see that all patients with ulcers had the infection. So at that stage we said, yes, the infection seems to cause the ulcers.
That was clear cut to you?
By the time we finished the study, it was, yes. Because there are about 22, I think, patients with ulcers, and they all had the infection.
So for you, it was seeing is believing?
Yes.
All right. Good. Okay, seeing is believing. I think you have a gang here. Please, lady, please.
I have nothing to do with physiology or medicine, but I have a question on this subject. It's about recycling. Recently, it seems like a fashion that fat people eating skinny people's poo will make them lose weight. So my question is, what kind of bacteria that does this in the gut? So that's one. The other question is the converse true? The skinny people eating fat people's poo will make them gain weight. I'd like to hear your enlightenment. Thank you very much. This is about recycling, so nothing go to waste. So you can actually purchase these pills in Boston. That's what they launch, and they're going for clinical trials in the General Hospital in Massachusetts. Yeah. So I'd like to hear your views.
Can I rephrase the question to what is your opinion about the gut microbiome?
That's the question. It's very interesting. This university.
Well, the gut microbiome is very important. It has to stay as it is. It develops very quickly in young children. And if we muck it up, it makes people very sick. This was fairly soon found out by doctors in hospitals when they gave patients very powerful antibiotics and mucked up their microbiome. And then they've got over-infection with other bacteria which normally wouldn't grow there, but suddenly because the normal bacteria are partly disappeared, these other bacteria, particularly a variety of Clostridium, would grow in the large intestine and cause quite severe inflammation there. It could make people very sick, even kill some of them. So the microbiome, the normal microbiome that you've all got, is very important. Is that what you want to know?
Yeah, I think so, because I think, the bacteria is very important. I don't necessarily have to go in via the poo, because there will be alternative ways or more sophisticated ways. But you should remember one thing, that you have more bacteria in your gut than you have cells in your body. So bacteria are very important. But how we eat them is another discussion that we soon gonna have dinner tonight. So. Okay. Can we have some other non-dietary questions, please?
I'm Devashish Demunshi, and I'm a graduate student at CQT. And I actually have a question for Professor Warren, and it is about science communication and the current structure of science, how we tell about our experiments and our discoveries to other scientists. Most of the time it is via journals, and when we submit our work, only a very handful of people, sometimes two, sometimes even one person, judges the merit of that work, which seems to be, can be highly subjective, can have strong subjective bias. So my question is it possible to develop a alternative system of communication which will not have a bias like this? And why I'm asking is maybe because you've faced a similar situation with your discovery and your background.
Communication science, how should we do it really? Yeah, of science, instead of just, putting it in a journal of biological chemistry or something like that,
Well, it's becoming very difficult now because so many people are forced to try and publish as many things as they can to get a job. And people tend to try and publish articles as long as they can, and I think usually it's probably better for them if they publish shorter articles so people read them. Sorry?
It's more about the evaluation of the work. How do you evaluate a scientific work?
Well, the evaluation of the work, I've never been involved with it, but except that for our own work we had trouble publishing our original article.
I'd like to make a comment which is slightly different than what you said, but it's the same subject. I'm saying that there is a fundamental change in the way in which one carries out physics, in particular, science in general, over the famous 32 years which passed between my Nobel Prize and today. And this is coming from the fact that instead of having a single group of few people doing a certain activity more or less in isolation with the system, you're constructing much wider and more complicated system. The example, for instance, being the CERN case, where there are even thousands of people which are working together, each one contributing to one particular subject, which put together gives you the story as a whole system. And this kind of process, of course, is associated with internationalization. You have this phenomena which does not localize to a given place, but there are always pieces which are developed here, pieces that are developed there, things which are coming out from a third place, and all together they build up a system. Which implies that at the present moment, for instance, you mentioned the question of a Nobel Committee. The Nobel Committee, in all activities except the one for peace, you require a maximum of 3 people to perform an experiment. For instance, let me give you an example of the discovery of the Higgs, which was a very fundamental discovery which was done 2 years ago. And that was done by a very large number of 6,000 people who worked together. But the prize was given to the theoretical prediction at the beginning. In my view, it should have been also a proper experimental demonstration of the fact that we have discovered a new scale of particles, the Higgs, etc., etc. But this is not possible because you cannot take 3,000 people given a prize. And therefore you have a problem there, which is coming from the fact that you have to understand how to organize a system in a totally different way, which also implies the values that you mentioned to be different. In terms, and also globalization is a fundamental element, which is very difficult to represent. For instance, the development we did about 20 years ago about the web, there is a demonstration of this. The web was created essentially in order to make scientists the ability to participate in real time in an experiment without being there. In the old days, we were accustomed to go, if you want to do an experiment in any field, you were getting yourself the best place where things was done. Then you're going there, taking your wife, your dog, your family, and everything there, and sit at the job and work from night to day and get the whole thing finished. This was not possible in elementary particle physics because the complexity, because of the fact that there are one big experimental program in America, one big experimental program in Japan, one big experimental program now, I suppose even in China and in Europe. And under those circumstances, how can you develop a system which is communication on a global level? And the web, which we developed at CERN during the time in which I was director, in fact is essentially an indication, was done for the scientists. Was not done for the big public, it was done so that science they could communicate in real time. Somebody sitting in Berkeley could work as he was in Geneva, because the communication was permitted through this particular information coming from computers, etc. This is implying a fundamental change in the way we are doing science, and you people in the future will have to realize that the science is no longer going to be done in the same way it was done 30 or 40 years ago.
Good. Question there, please.
Yes. Good evening, gentlemen. I don't think the microphone's working, but I'll just speak loud. My name is Lucy Ford. I'm from the United States, and I was wondering, how do how do you suggest that we decrease the time delay between actual scientific discoveries and practical implications?
Yeah. How do we make discoveries more efficient to decrease the leeway between discovery and application?
Essentially, this is a real problem because the NIH, for example, push for all of this keyword for having science useful, and they push, in my opinion, too strong. It's opposite than your question. The way science works is that people with curiosity discover something, and eventually it becomes used for society. So the idea to move from the discovery to general use is not always so good. I mean, it's too much pressure on scientists who will make major discovery. So the last 10 years there was huge emphasis by the NIH of this philosophy to shorten the time between discovery to clinical use, and it did not appear to be too useful. Now, maybe combining scientists with commercial companies could do it, but the time needed for it is kind of a fact. I don't see how you make it faster.
Okay, anyone else want to comment?
May I say one thing? Since you are very close to the Nobel Committee and Nobel Prizes, very close to your activities and so forth, I would like to say that the delay is not so much in making the discovery and get it recognized properly. For instance, about the Nobel Prize. I know cases of people which have been recovered the Nobel Prize 40 years after the original discovery. And this is something which, in my view, has a lot of significance. It should also be taken into account that it is not so much to carry out an experiment or a discovery, is the fact that discovery has to be understood and agreed by the community.
And confirmed.
Because most explosive discoveries are usually forgotten by many people for a long time, because people tend to be conservative. And the conservativeness is developed itself in a particular... I've been very fortunate to get the Nobel Prize a year after I did the discovery. But this is not the rule. This is an exception.
Yeah. I mean, I think what we say here, everything should be done as fast as possible, but not faster, right? And I think it's very important to understand that one discovery from one person may be wrong. And you don't want to develop a drug or a medical development for information that is not correct, you know. So I think the system has to be conservative. Of course, one should try to develop it after a while, but having things confirmed by others, reproduced, we say, is very important also. Okay, more questions? I see many hands. That you put yourself very strategic there, so let's go.
My question is for Prof. Warren. Earlier in your introduction, you spoke about the resistance you got from the scientific community to your work. What about the resistance from the non-scientific community? I'm hearing now the anti-vaccine movement, for example, in the US, diseases are coming back which have been eradicated years ago. This is from a non-scientifically trained, and I think the rise of the internet has been a vehicle to bring this so-called anti-science movement in the forefront, and I would like to hear from you how the scientific community can go about addressing this.
Yeah, I think that's a really important question, actually, because we say everything that is on the internet may not always be true, but for non-scientists it may appear true. So, do you have a comment on that, Warren?
Yes, well,